Hi, this is Python for neuroimaging for beginners, the last session. So well done, everyone. Again, this is for someone who have no engineering background and who have interest in learning Python to apply in neuroimaging. But today is about tables and figures, and I'm sure it applies to many other people who are not even working with neuroimages. All right. So table is basically a data set arranged in rows and columns like an array. So it looks like an array, right? But this time, each column may have similar data type representing specific things like name or age, a random code or something, all right? And in your imaging, we have many projects and many subjects and bunch of variables, and we tend to work with tables a lot. For example, different labels and for different ROIs and free suffer are they are arranged in tables. And say you are extracting an FA value or volume or connectivity measure, they are in CSV file or Excel file. And even the demographic informations are most likely saved in a table format, all right? It's not only neuroimaging people, but everyone works with tables. So there are bunch of tools that takes a table as an input and then does very useful analyses such as correlation analysis, network analysis, and creating figures and so on, right? But here we are not trying to create this tool. What we are trying to do is focusing on table manipulation so we can make the tables in the right format, ready to be used in those nice softwares, right? Today we'll be using Pandas and seaborn. So Pandas is like a Microsoft Excel for Python. And seaborn is a good example of the software that takes Pandas table as an input and draw nice figures quickly and easily. Okay, let's get started. So let's open Jupyter Notebook like this. And let's create a new notebook by clicking on new. And you can do Python 3 or Python. Since you have installed your Python using Anaconda, they will have all the modules that you need anyway, okay? All right, let's import these functions first. I'm going to import Pandas, and I'm going to call it as a PD because Pandas is quite long. And then I'm going to import matplotlib anyway. We're not going to use much, but I want to have it if I want to do something as PLT. So this is too long, so I'm importing as PLT. And I'm going to import seaborn. And this is too long. I normally import it as SNS and then import NumPy as NP. It's good practice to import those 4 things whenever you work with Python because they are quite useful in most of things. And then again, matplotlib inline. You have to do this in order to show your figures embedded in the Jupyter Notebook. Let's run them by Shift Enter. Then it runs the cell and creates an extra cell in the below. So it's quite useful when you are scripting in the Jupyter Notebook. Shift Enter. All right. So next, let's create a table that looks like this. Okay. I'm going to create a table looks like this. So I'm going to use pandas dot data frame. Bear in mind D and F are capitals, and then open brackets, and you give data. So each row has a Kevin and Seoul and Haha and Boston. So first row is Kevin, is strings, right? We have to put quotation mark and Seoul. That was the first line. And next row comes here, Haha and Boston. But since the data requires one object, we merge them as a list like this. Okay, try Shift Enter. Now we create a table that looks like this. All right, I can store this information in a variable called df, shortened for data frame. I'm going to use this df. All right, there are times when we want to do different naming of the columns. Say I want to have a column name of subject here rather than 0. I want to have city here rather than 1. What you do is when you're creating the data frame, you give extra input afterwards called columns. And then give the list of columns that you want to have, subject and the city, like this. All right, I'll do Shift Enter, df, Shift Enter. So now it has a subject and city. So subject and city, they are called columns. And each row has this lettering in front of that in bold. They are called index. So this is the kind of key that is used to refer to the row. All right. Row 0 is the first line. Row 1 is the second line. Okay. So how about you create this table now using Pandas? Create them now. Bear in mind, we don't create much. We don't actually create with hard coding with Pandas in our research environment. This is just practice. All right, let's do them together. PD data frame. Data is, we have different rows. So I'm gonna open on a list. And first line, Kevin. So age is numbers. So I'm not gonna use quotation marks, 31. Next line, Coco, Boston, 20. Haha, LA, 66. Then Chris lives in San Francisco. And step 3. All right, and it has column of subject, city, and age. Columns, subject, city, and age. Age. df. Run them. Yep. Now I got a table that looks like this. Kevin, this typo. Fix this. Yep. Okay. It's pretty simple. Okay. Do you remember last time when we were doing NumPy, we were selecting the part of the array that we wanted by giving the specific rows and columns? Same here. So if you want to select the first row, what you do is df and dot. You have to give lock. It might be confusing in the beginning. It's confusing for everyone. Don't worry about it. It's just not you, but it is the way it is. So give the index number 0. Then it returns what is in the first row. So what if you do this? Return something in the row with index of 1. Try the 3. Yep, returns the line with the index of 3. Let me just check what kind of object this is by doing df log 3. So it is Pandas series object. So df was Pandas data frame object, and each row is Pandas series object. So data frame is just a bunch of Pandas series stacked up together. All right, let's do some more than that. Let's select 2 lines. df.log 2 lines, as we are selecting more than one thing into the catching input. We have to give them in a list like this. Now it's grabbing the rows with index 2 and 3. All right, now let's select by columns. df, for columns, you don't need lock. I think it is because in tables, we mainly work with the columns rather than the rows. So I think Pandas was designed this way. That's what I think. If you do subject, it catches the first line. Kevin, Coco, haha, Chris. Let's catch city. All right, is getting that column. This is also Pandas series. So it's data frame is bunch of Pandas series. You don't have to know that. All right, how about selecting something like this? let's select that part. Have a guess. So df lock 2 and 3, and I can select subject and city. But since I'm selecting 2 of them, I again have to put them in a list. This might be confusing. Don't worry about it. This is something, it's just designed this way. All right. Selecting this way. You may think the other way. df, you're gonna select subject and then city first. Then you can select 2 and 3. All right. All right. Okay, in the NumPy, do you remember we actually selected and then replaced the values like this, right? We selected rows and columns and replaced them with another value. We can do the same thing. All right, let's create another column that's called sex. Let's put different values there. So now df looks like this. Okay, just a little bit smaller. Okay, let's do extra. Let's add extra column called sex, and then in there I want to put M for Kevin, F for Coco, and F for Haha, M for Chris. Shift enter, does nothing. Let's check df. So there's, compared to the last time, there's an extra column called sex. Okay, you just added the extra column. How about we change this column? So now it was MFFM in below sex. Let's replace the value by selecting the column first by df sex, and then change the sex M F df. Right? You can replace the values like this. All right. How about we adding new raw like here? So it looks like this. Now let's add a new raw with index 4. So df log 4 equals new name and whatever city that you want to put, and 14 female. All right, shift enter, nothing happens. If you check back the df, there's an extra raw called new name with the index of 4 that you've given. Okay, what if we don't provide the full values there? Let's do that. df log, I'm going to do 5. I just want to provide subject name, like here. Subject, only subject. I'm providing only subject rather than the whole list like this by doing, not closing the brackets and the comma, the column name. Unknown. Let's see what it does. So it created another raw with index of 5 and subject field, subject column filled with unknown, but the other values are empty. All right, it just fills the spot where I specified and the fills nothing on the other cells. All right. Okay, and let's try this. It feels like the df index must be a number, but it doesn't. Let's do df log new index like this, and subject equals unknown again. Let's see what happens. So now I'm not providing number here. I'm providing strings. Let's see. So my index is new, is mixture of variables. It doesn't have to be a number. All right, it doesn't have to be a number. Okay, if you don't get it, never mind. It took me a while to get used to this, but just bear in mind you can replace the stuff by selecting columns and more. Okay. Okay, let's so we just saw that index could be something different than numbers. Let's try changing the index. Say df looks like, sorry, df looks like this. Now I want to make the subject as the index rather than this numbers and new index. What you do is dot set underscore index, and then select the column that you want to make into the index. Subject, like this. Right? Now your table looks like this. And then I want to store this, but bear in mind, you've done this, right? But df is still this because you haven't updated your data frame. Okay, in order to update your data frame, you have to set a value like that. Now df new has the index with the subject. Now you can get the rows with the index, right? I can get Diane if Diane was there. I can get Coco get. I can get Coco if Coco is there, right? And I can add new numbers like this. Diane, she's in London, 18, female, df new. Diane is here. Okay, it's just adding new numbers, selecting. Okay, let's do calculations. So if you look at the df looks like this, and there's an age, column of age, which is in numbers. If there's numbers, we can calculate stuff on it. Let's do df age times 33. Let's multiply 33 to the age column. Then what it do is it applies 33 to all the columns. Okay, df looks like this. It applies 33 to all the columns and returns a series. I want to store this in a new column called age underscore 2. Let's see what happens. So age 2 is a 33 times age column, and it stores the information in the age 2, right? Since it was empty, we don't have anything here. But for the data, which is there, we multiply by 33. We can also do, if we can do multiply, we can do a bunch of other things. df age 3 equals df age 2. Take away df age. So this is taking away age column from the age underscore 2 column and storing it to age underscore 3 column. All right. Okay. We can also do something similar to the strings too. So I want to create a new column called new name, and I'm going to select subject column, which is this, and I want to add underscore haha to it. See how it looks? See? So you can apply something, you can multiply, you can add, you can append letters to whole column. All right? Okay, now removing the data. You just added it, you just changed it. Now let's drop some of the items. So you can drop raw by doing dot drop. So let's drop the 5 and new index. Dot drop, open parentheses, and then 5. No 5 now. But let's check let's check df again. There's still 5. Because when you drop the number, it just returns another data frame without index 5, but it doesn't actually update the df itself because you don't want to delete the data that easily. Okay, so what you normally do is df equals df drop 5. Okay, now let's check df. There's no 5. Let's drop new index. There's another way of doing this. Drop new index, and then you can do in place equal true. If you do this, it updates the df by removing new index. Let's check df, right? There's no new index anymore. We can also drop the whole columns by giving axis 1 option to it. So let's drop new name column by dot drop new name, and then you have to provide axis equal 1 because you're not dropping from the index, you're dropping from the column, and then in place equals true. df. See, new name is dropped. All right. Okay, now we are only working with examples with 5 lines, but it will get difficult. But let's try this before we go further. So there are times when I want to select certain subject, say a subject who are older than 20. We have age column here. It can be really easily done. Let's do df.age, which is greater than 20. Let's try doing this. Then it returns a series of Boolean, which is true or false, like this. And I can use this information to select the part of data frame, like this. You put that the condition inside the brackets, and then run it. Then it's getting the rows who have the number in the age column greater than 20. We can also add another condition to it, extra condition, not only one. So give them inside the parenthesis, and then give an and sign and open another parenthesis for another condition, df sex m. So this time I'm only getting subject with a number greater than 20 in the age column and an m string in a sex column, right? Returns only one subject. Okay, let's try this then. So df has a city column. I want to collect the rows which has either Seoul or LA as a value. Let's try city. City dot is city in this list, Seoul or LA? Then it returns true or false. I can use this information in brackets and the F to return the rows that corresponds to the true. Okay, 0 and 2. All right, Seoul or LA. Well, it's an example you will see when we use this. So we can do something like this as well. You want to search through the city strings, right? df looks like this, city strings. I want to check each strings and see whether that string contains letter C. All right? Contains, sorry. Okay, it returns Boolean again. Then, I can use this value again to select like this. All right? Let's change the value E. O. F. No raw with small f in the city. Okay. Okay, let's pause. This is something that could be confusing, but bear with me. It is very useful thing. There's a group by function. So when you have a bunch of values in a table, you can split the table into each specific variables and apply something. Let's just have a look at it. So for the sex, we have female and male. There are times when we want to apply things to female table to male table. Let's try this. df group by sex. It returns a group by object. Just let you know. And dot mean. Try this. What it does is for the all of the unique variables within the sex column, which are F and M, extract mean values. So for females, age 1, mean is 26, male 43. We can also do standard deviation. So standard deviation is much larger in males for age. Okay, and you can actually make a function for yourself. I'm just showing you for the basic things, mean and standard deviation, but you can do z-score transformations, and there are a bunch of other things. Okay, so this object, this group by object, you can actually loop through them. So sex will be unique value, and table will be the table that corresponds to the unique value in df group by sex. You can loop them, print sex. So sex is female and male. Let's print table this time. So first table is the female table, and second table is the male table. All right. So now you're controlling the tables. Now you're controlling tables, you're changing the values, appending new columns, appending new rows, deleting them, dropping them, and replacing them and calculating stuff on them. Okay? You can save the data frame, of course, into CSV or Excel file. You can do to CSV, new df. You can give whatever name that you want to. CSV, let's save them. Let's do ls. So there are this file created just now. I want to see how it looks. It looks like this. So this is a plain text format. So you are saving your data frame into a CSV file. You can also save them as an Excel file like that. df to underscore Excel, open brackets, udf. Let's give random names. Excel, XLSX for the Excel extension. And then name of the sheet, do you remember in Excel spreadsheet, you have name of the spreadsheet, all right? So ls, you have your Excel file created. Let me show you how it looks. It looks like this, all right? Okay, now it's getting boring with the tables. Don't worry, it's figures now. Okay, let's draw something. Let's actually draw something. All right. Okay, so your data frame looks like this. Let me use seaborn, which is a module, very powerful and very simple to use and easy to use. And in the seaborn, there's a thing called catplot. And how to use this is you just give the variable they want to put it as an X variable and Y variable. X variable, I want to put a subject. And for Y, I want to see the age of each subject. And then where is the data coming from? It's coming from the DF. It's quite quick, isn't it? So Kevin, 30-something, Coco, 20-something, haha, very simple. I can change the type of the graph easily by giving kind option. I want to do bar graph. It's quite good, isn't it? And I can divide them by raw, and I want to visualize different sets on the raws by giving raw option. So different raws represent different sex, top female, bottom male, right? You can visualize much things from it. You can change this as a column. Okay, so there are a few points that you use. Raw, you give X and Y, where's the data coming from, what kind of data, what kind of graph that you want, and what do you want to split the columns and row of it. All right. Okay, we can also try seaborn, catplot, X. This time I want X to be sex and then Y to be age. In this graph, I will be seeing differences in age between sex. Data is coming from DF, and I want to plot them as box plot. Right? It's very quick. Very, very quick. Okay, let's read the example part. This DF is too simple. All right. We don't normally create data frame with hand anyway. We will have bunch of subject, bunch of lines. All right. Okay. This is how you read CSV files. So pd.read CSV, open bracket, and your data. But if you have your own data, you can open it now. But let's work with my example if you don't have anything. So open them like this. I have uploaded example data up on the JIT. So you can download it like this. So give the URL first. It's a long line, isn't it? Let me copy this into chat. Chat. I don't see a chat. Okay. Yeah. Do something like this. I'll type as raw.github usercontent.com kcho python workshop / master data python _4 demo _df csv. Okay, I'll just set the URL and I'm loading data frame into demo _df and I'm reading it with CSV file URL. This can actually download the text file saved up on the internet by using the same command, right? Error, bad lines, false, you don't have to know this. And I want to have my index, which is in the first column. Let's see how it looks like. Demo _df. It's a very long text file, okay, with 409 rows, and it has column of name column, date of birth, and it has sex, and has a scan date when the MRI was scanned, and group whether it was healthy controls or schizophrenic patients, and intracranial volume representing how big the brain was, and how big was the thalamus. All right. Well, bear in mind this is fake data, but still we can practice much on it. Okay, this is how you look. But whenever you type demo df, you're gonna print a bunch of stuff. You don't want to do that. All right. What you do with the long df is dot head. Just want to print 5 top lines. Just want to print 10 top lines. Okay. I normally do just head like this. Okay, let's see what the data is. But since we loaded data from the internet, the demo df doesn't know what kind of DOB and scan date data type is. I want them to be date data type rather than strings. So this is in letters right now, but I want to change them into date format so I can assume the age at the scan of the date by doing this take away that. Okay. All right, let's do df demo _df dob date of birth. Let's see what that is. Let's get the first value of dob. It is strings right now. I want to make them as a data type. Okay, how you do that is dob equals pd to date time demo df dob. So I'm converting something into a date format, and I will do the same for the scan dates. Scan dates. Scan date. Demo. Yes. Doesn't change anything. But if you look right now it's a timestamp rather than a string. So what you can do is you can do scan date, take away demo df, date of birth. It returns in days, so it can be your age at the time of the scan. Okay. And I want to save this information in the age column like this. But since we don't put age in days, I want to change the demo df age by dividing them with np time delta 64 1, and this just basically means I want to represent it as years rather than days. Demo df. See, now is in years. Okay, let's plot something. So there's something called count plot, seaborn count plot. So you give what kind of variables that you want to choose as x-axis again. I want to see how many people there are per group. So give x as group. And this time I want to choose color, different coloring for different sets. Okay, data comes from demo df. Nothing much changed from cat plot for the count plot. Is very simple to use. So it just returns the count for healthy controls and SPR. We divide them by color, male and female, all right, and then just counts them. So without going through all the data frame that you have, demo.df, like going through them, you can now just by looking at the graph, just tell how many number there are for each group, for each sex. 90 something, just over 100, 90 something, almost 100. All right, let's try catplot again. SNS, catplot, X. So this time for each subject, X, name represents subject. All right, name represents subject. And Y, I want to plot date of birth, and data comes from demo.df. So y-axis is date of birth and x-axis is subject. Taking a while because it's time data. It's quite heavy calculations. So this is subject. Each subject were born between 1984 and 2005, I guess. All right, you can visualize like this. And what if we divide them by group? Give me a sec. Divide them by groups. We can check the date of birth for each groups. It's taking a while because it's date time format, right? So I don't see any patterns of specific difference for the birthday. Let's try this on age column. So the age at the time of scan for each groups. Or maybe it's because the data point is quite a lot. Yeah, so age is between 14 or 12 to 35 for each groups. I don't see any specific patterns for health controls and schizophrenics. All right, you can also add raw sex like this to see whether there's any difference specific for column as well as raw. Okay, let's give a bit. Okay, let's go on to the next graph. This will complete it. Okay, let's plot something else. Yep, okay, looks like this. So this time, the column represent groups, health controls, schizophrenics, raw represent male and female. I see no patterns in them. This is how you check the data, exploration of the data. SNS, let's plot X equals group, Y equals demo df. There was a thing called ICV, intracranial volume, ICV, and hue, sex, data, demo df, and kind. Oh no. So I want to plot the box plot for each group, looking at the ICV per each sex. Right? So female has smaller ICV than males, but between health controls and schizophrenics, I don't see any strong pattern of difference between them in the ICV. Okay, we can do the same for the thalamus. Thalamus volume. The thalamus, I don't see any specific difference between the groups. It feels a little bit lower, but I don't think it may be significant. And for sex differences, there's a slight reduction from the male in health controls, but for schizophrenics, similar. This is how you understand the data, by plotting. And we can also look at the correlations by something called reg plot. So is thalamus volume show linear correlation with ICV? So for the x-axis, thalamus volume, and ICV, Y, I don't see this line, which is line of best fit, going upwards. So I think the gradient for this line is almost 0. So there's no correlation. But this is because I just generated from a Gaussian distribution. We can also try this. I really like this plot, LM plot. So thalamus volume and ICV, now you can split the graph by seeing patterns in each group. And also I want to see patterns in each sex, like this. Right, so colors represent groups, healthy controls, green, and orange, schizophrenia patient, upper graph, male, and lower graph, female. So the correlation, which was not that much strong, is in actually in different direction in the females and is much greater in schizophrenia patients than healthy controls. Okay, you can quickly understand the data like this. All right, there are a bunch of more figures if you go in them, and I just wanted to show you the examples. If you go in there, there are a bunch of examples. You can use all of that to figure something. And if you, where's joint plot? Okay, pair plot. If you go into pair plot, there's the examples that you can use. So it's just basically loading a data and then plotting them. So what you do is you just copy this, come back to your Jupyter notebook, paste it. What you do is you just change the variables. Your data goes in first, demo df. Y variable can be ICV, and X variable can be sex and group. As well. Let's remove this. Let's remove this. Okay, you have to put, there was something else behind it. So there's another thing, actually, which is actually drawing. So you put this in, SNS, whatever, and run it. Oh, G. Yeah, so it shows a pair plot. There are a bunch of examples in there that you can do. Joint plot, you just copy this. Paste it, change it to age, and then ICV, data into demo df, and reg, delete everything that you don't know. Okay, showing nice graph of examples there. Swarm plot, there's also swarm plot. Let's just try swarm plot. Swarm plot. What you do, you just copy it and paste it, change your measurements. Swarm plot group, X can be group, and Y can be thalamus volume, hue can be sex. Delete, you can delete, and data is coming from demo df. Okay. And there's a rel plot. Let's go to rel plot. And again, let's just copy them. This is for the last time. Let's copy them and paste it. Let's change data into demo df, delete all the things that you don't need. Let's keep them. ICV, thalamus, volume, and hue can be group, and this can be size, can be age. So this produces a graph that the size of the dots representing age, so greater the circle, the older the subject, and color of the dots representing groups, and X ICV, Y thalamus volume. You see my point, right? There are other volumes that you can do, a bunch of other volumes, okay? How about we take a like 2 minutes break and questions as well? Is it too fast or is it too slow? Yeah? Is it okay to go on? I think I've made too much slides. There are few more. Should I just go ahead? It will take about 10 minutes to go through.
Yeah, keep going.
All right, I'll just do 10 more minutes without break then. Okay, the figure is finished, but next part is something that is quite important. So back to tables, melt and pivot. I'm not sure whether you have worked with tables in different formats, long format and wide format. There are times when we have to change the format into the right one to use tools like seaborn. Sometimes we have to melt them. Sometimes we have to change this long formatted data frame into wide format by using pivot. Okay, so this time let's create a table, fake table called UDF. UDF PD data frame, and then I'm gonna copy the name from the previous demo DF name. So UDF, if you look at the UDF, it looks like this. Okay, and I want to add a column called left hippocampus volume, and I want to get a random value from a normal distribution, which is mean 2,500, and then 500 standard deviation, and has a length of same as the demo DF. Okay, I must have made a typo somewhere. Okay, so I just made a fake value coming from a normal distribution for the left hippocampal volume. I want to do the same for the right hippocampal volume. Okay, so DF, oh my bad, I made a typo here. Must be UDF. UDF. Okay, now UDF looks like this. So it has a column of left hippocampal volume and right hippocampal volume. There are times when I have to have each rows for hippocampal left and another row with the hippocampal right. Okay, that is melting. Okay, you melt it like this. You melt it like this. So now it is wide. We call them wide format. We have to put them into long format by melting it. The UDF long is PD melt. UDF is the input, and ID is name, and value. What do you want to melt? I want to melt value vars. I want to melt left hippocampal volume and right hippocampal volume. Okay, and I want to call them var name. I want to call them, call the column called side, and value name is volume. It can be confusing, but just know that there are ID vars, value vars. Yeah, just know that there are functions that can change your table that looks like this into this. So now each rows has one volume that represents to each side. Okay. Some tools require long format. Some tools require wide format. That's how you do them. So, all right. Now let's merge the tables. So demo.df looks like this. You don't have hippocampal information in this df. You have hippocampal information in another data frame, and now I want to merge them. How you merge them is like this: pd.merge, and you give the two df that you want to merge, which is demo.df and udf. Say this is like this. When you have all the values like fa, another array provides you with spreads with age, and you want to merge them together in a single spreadsheet so we can use them as a covariate. So what you do is like this. So you're merging the key, the one that overlaps is this name. Name here and name there. If you use like this, it will merge the tables like that. So spider, left hippocampal volume, February, left hippocampal volume, like this. So it finds it merges two data frames together based on an item. Okay, so it better do like this and have left hippocampal volume and right hippocampal volume as a separate sys. All right. Okay, I will just skip one part because that may take too long. This is the last example. I include this because I thought it could be useful for QC purposes. Let's load the data frame like this. So it looks like this. df has a bunch of columns: name, array shape, and volumes, and diffusion bvars, volume, diffusion vol, v-vector shape, model, and QC scores, and comment directions. Okay, now you probably know what this is. This is a QC table of diffusion weighted volume, the raw data. So it looks like this. There's a QC, there's each subject. So the spider subject had QC value of 2, which is okay to use. For machine subject, QC value of 3, flight subject 3 as well. And there are comment directions, the comment for this subject. So there was a signal drop at flight volume 17, signal drop in volumes like that, slight motion, severe motion. Okay, you have a bunch of data like that. Let's use seaborn to count them. Count plot QC score average. So this is, I'm plotting each QC score averages, which will probably range from 0 to 5. And then I want to count them using seaborn count plot data df. See? So there are quite many subjects who were scored 1.5, which is not useful. And there are many subjects at the boundary, at the 2. Some subjects have really good quality of data, but similar number of subjects is unusable. All right, you can just get the figures like this straight away. All right, you can also get the count in tables, df. You can group by, also it is multi-site study, so you have different sites included in them. Let's do this, group by site QC score. What you do is you're grouping by each site and each QC scores and then counting them. So for site 1, you have 10 subjects which have 1.5, 11 subjects which had QC average 2, like this. This site 2 is good. Many subjects with score 3, but still it has 1.5 and 9. We don't want to lose that much. And 1 is really bad quality, and so on. You can save that information somewhere, or you can plot them. Okay, let's do that. Oh, you can simplify graph, simplify this table like this by putting a column to it. So get a simplified version of the table. And you can make it nicer by resetting index, making back into the table. Okay, let's do a cat plot. So let's use this. We're going to use this, but we're going to create cat plot. Cat plot. X will be QC score average. Y will be name, and column will be site, and core rep. So each column should have no more than 3 columns. I mean, each rows should have no more than 3 columns. And data is the thing that I just did, which looks like this. Which looks like, I'm using this in today. And I want to get a bar graph. And what it does is that it creates figures for each site. And X is the QC scores, and name is the count of subject that falls into that QC subject. So by looking at this graph, okay, this site has really good numbers, right? QC score is going quite high. And then if you look at this site, so many subjects at the boundary, actually lower than the threshold. This site, there must be something wrong systemically. This site evenly spread, but we can tell the site to try a little bit harder to collect in better, to reduce the motion of the subject or something. Okay, we can look at the data like this. Okay, this is something that I'm not going to do. So there are comments if you look at the DF. So there's a comment. You can use Python to extract values like signal dropout, how many were there, and were there letters called moderate motion for that raw. You can do that and then create a figure like this. So to explain this figure, for each site, for each subject who had less than low QC score of 2, I want to plot them. I want to give them name and the site, and give the QC scores in a square patch, and then extract all the words, signal drop, EPI distortion, motion, in the DF comment directions. And then if there were words included in the DF comment, mark them. So by looking at this graph, I can tell, okay, the site 8 had consistent errors, mainly coming from signal drop, EPI distortion, and motion. And some of the subject, like case subject from site 8, also had ghosting and cut effect, but pattern changes for site 7. Site 7, we had not much signal drops, but still we had EPI distortions and motions. Also had quite many ghosting for this site. We can see, we can visualize the strings quite easy, not quite easy, but we can do it in a very useful way. Okay, that was it, and there are practicals. I included the script for making this figure, so you can try that. So please try it, and maybe we can utilize it in the P&L pipeline. That would be really nice. And this is practicals. This is actually using all of the things that we've done for the 4 steps, 4 sessions, 4 Python sessions. And quick recap. We did the data types, loops on the first basics, array manipulation on the second, pipelines, functions and class, and tables and figures, pandas and seaborn. I think you guys are quite ready to start learning Python now. You can almost say you know Python. Now it's time to apply them in your own project. I'll be happy to see you using Python, and anytime when you have a problem, you can ask me anytime. All right? Thank you. Thank you all. I will stop